If you think you've missed your chance to see the northern lights this season, I'm delighted to inform you that you haven't. Most people associate peak aurora season with deep winter and faraway places like Norway, but some of the best northern lights viewing doesn't happen in the dead of winter at all. It happens around the equinoxes in September and March. And this March might be especially interesting, because the equinox isn't the only thing lining up. We're also near the peak phase of an 11-year solar cycle scientists have named Solar Cycle 25. I know, but naming it something cool wasn't a priority, I guess. Throughout these cycles, the sun's magnetic activity rises and falls. And right now, it's near its most chaotic phase called solar maximum. That name's a little bit better. During solar maximum, sunspots, solar flares, and coronal mass ejections reach some of their highest levels. Coronal mass ejections, or CMEs, are huge eruptions of energized particles launched from the sun's outer atmosphere. These eruptions blast outward with solar wind at mind-blowing speeds. And sometimes, Earth just happens to be in the way. Thankfully, our planet is shielded by a magnetic field that protects us from most of the solar onslaught. It deflects the incoming particles and funnels them towards the poles. And when those particles collide with gases high in our atmosphere, the sky lights up in shades of red, green, and pink. But why those colors? Different gases in Earth's atmosphere glow different colors when they're energized. Oxygen produces the classic bright green auroras that show up in most photos. But at higher altitudes, oxygen can also glow red, and nitrogen adds shades of purple and pink. The exact color of an aurora depends on the type of gas being hit by energized particles and the altitude of those collisions. Sometimes they appear as faint green curtains, and other times they appear as huge waves of color that stretch across the entire sky. For most of human history, seeing the sky light up in these bright colors was deeply unsettling. Before we understood the science behind auroras, different cultures tried to explain them in their own ways. In parts of Europe, the lights were seen as omens of war or disaster. And some indigenous cultures in North America believed that the lights were spirits dancing across the sky. Today, we know they're solar particles colliding with Earth's atmosphere. Slightly less mysterious, but still pretty cool. But even when you understand the physics, it still seems like you're watching something that's been computer generated. Solar Cycle 25 was originally predicted to be relatively mild. Instead, it's been pretty active. And that's one reason why scientists are watching this March so closely. It could end up being one of the most impressive displays we've seen in years if strong storms hit at the right time. It could also lead to some pretty big problems, but we'll get to those later. Because Earth's axis is tilted, our magnetic field doesn't always face the sun the same way. Twice a year around the equinoxes, the orientation of our magnetic field to the sun creates excellent conditions for a nighttime light show. During the equinox, Earth's magnetic field lines are more favorably aligned with the solar wind. That alignment makes it easier for charged particles to connect with our magnetic field. And as that connection gets stronger, auroras intensify. So between the spring equinox and the current solar phase, the northern lights could be some of the best we've seen in a long time. And you might not even have to live in a place where you have polar bears for neighbors to see the northern lights this spring. During these conditions, the northern lights are pushed further south. Last November, the lights were even visible as far south as Florida and Alabama. People who had never seen them before stepped outside and saw the northern lights overhead. Scientists also expect the auroras to be brighter and to occur more frequently. So what does this mean for you? If you're hoping to see them, keep an eye on the National Oceanic and Atmospheric Administration's website. They do a really good job of updating forecasts and predicting where the lights might be visible. One interesting thing about the northern lights is that they're actually happening almost all the time, even when you can't see them. Auroras are almost always glowing around the Earth's polar regions. And yes, there are southern lights as well. Most of the time, auroras are too faint to see or hidden by daylight or clouds. It takes the right combination of solar activity and darkness, along with clear skies, for them to really show off. As I mentioned earlier, along with a spectacular light show, we might also run into some problems. When a strong coronal mass ejection hits Earth, it can disrupt radio communication and interfere with satellites. It's not unheard of for communication and GPS systems to go down, which can cause a bit of an issue. And in some cases, it can put a lot of stress on power grids. In March of 1989, a geomagnetic storm knocked out an entire power grid in Quebec, Canada. Astronomers actually saw the massive explosion on the sun that led to the blackout. 6 million people woke up to no power, and it took several hours before the system was back up. But it's pretty wild that this same physics that create the northern lights can also cripple an entire power system. We live on a small rock orbiting a volatile star. We're bound to hit a few solar bumps along the way, but at least we get a cool light show out of it every now and then. And if the timing works out, we might get a really good one this month. If you're looking for more good news in your life, be sure to check out this video right here. And if you enjoyed this video, please give it a like and consider subscribing so we can ignore all the bad news together.